So we are going to do part C. So part C of this related rates problem. So this is the last part, and the question asks, find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall. So we have to figure out, first things first, is what they're asking for. So it says, find the angle between the ladder. So if this is our ladder and the wall, and if this is our wall, if it's the angle between them, it's asking for this theta. So find the rate at which the angle between the ladder and the wall is changing. So if we're changing our angle, it's d theta dt. So how is the angle changing with respect to time? When the base of the ladder is 7 feet. So if we're going to consider this the base of our ladder as x, right? We can say x equals 7. Well, if we say x equals 7, based on the given equation that we have before, that we found in part A, we can say y is equal to 24. You just plug in and solve. And since x equals 7 and y equals 24, that means we have dy dt is equal to, and if you've already watched part A, you would know the answer to this. If you have not watched part A, go watch it so you can figure out how to find the answer. But dy dt is negative 7 over 12. So now we have x, y, dx dt, and dy dt. So we are quite ready to find this answer. So how are we supposed to relate all this in an equation? Well, if we look at this, if this is our ladder, our wall, and our base, we have x over here, and we have y over here, and then we have 25. Well, we want to relate theta to x and y because these are variables, these are changing. So we're trying to figure out what is our angle and how is it changing when x and y are at a certain value. So if we remember from so, ka, and then toa, this looks like an opposite over an adjacent. So we're going to use tangent of theta. So we're going to say tangent of theta is equal to x over y. So now we have an equation. And now we can take implicit differentiation. So we can derive both of these and find d theta dt. So let's do that. So we have the derivative of tangent theta, which is secant squared theta, and then times the inside of secant squared theta for chain rule, which is d theta dt, is equal to the derivative of the first times the second. So we have 1 over y times dx dt plus the derivative of the second times the first, and that gives us negative 1 over y squared, that's the derivative of y, times x over 1, like we had, times the first, and then don't forget our dy dt that we had because we took the derivative of y. So we have this equation right here. Well, I want to get rid of the secant squared theta. So if I divide by secant squared theta on both sides, right, that's the same thing as multiplying by cosine squared theta, because secant squared theta is really 1 over cosine squared theta. So if I just multiply both sides by cosine squared theta, that will cancel out this, basically secant squared on this side. So we have the theta dt is equal to cosine squared theta, and then times our whole expression over here, which is 1 over y dx dt, and then minus x over y squared dy dt. Now we just have to plug in our answers to find what is the rate of change of our angle as at a certain theta x y dx dt dy dt. Well, if we're looking at equation, we have our y, we have our dx dt, we have our x, and we have our dy dt, but we don't have a theta. So how are we supposed to figure out what theta is? Well, it says cosine of theta, and then all of that is squared. If we look at here, cosine of theta is adjacent over hypotenuse. So we say cosine of theta is equal to adjacent y over 25. Well, we already know what y is. We said y is 24. So cosine theta is just 24 over 25. So if you plug that into here, we get the theta over dt is equal to 24 over 25 squared times 1 over y, which we said is 24, times 2, which is dx dt, minus x, which is 7 over y squared, which is 24 squared, times dy dt, which is negative 7 over 12. And our answer will equal to 1/12, and then we say radians per second or minute, depending on what our time interval is. But that's our answer. So that is how we found the rate of change of the angle between the ladder and the wall as x is being pulled at 2 feet per second, as y is going down at negative 7 over 12 feet per second when x equals 7 and when y equals 24.